this video is to discuss a project I worked on last year. The name of the project was something we titled Building an Affordability Model, and the goal was to predict or estimate a monthly maximum affordable offer for a micro business loan client. Now, why was this problem why was it a huge deal? Why was it important? So typically, we give loans to we give two kinds of loans. We give personal loans and we give micro business loans. And so for people who ask for personal loans, people probably who work in an organized sector, they have a consistent source of income. We can trace or tie their income back to a particular institution. But for the micro business loans, guys, there's some complexity involved because first and foremost, these guys, you can't really trace what their income is like. They don't have a consistent sort of income, and also they're more subject to external shocks like economic shocks, maybe some foreign exchange rates increase, or maybe some sort of the pandemic. They're so much more susceptible than the people who ask for personal loan. Hence, there's a greater risk. There's a risk cap when it comes to a risk band when it comes to those customers. And as I was made aware of, we're really no financial credit institution or playing in that same industry space that has built something that can adequately estimate what you can offer someone who a micro business loan owner, and then they'll be able to replay, and you as a company, your risk will be low and you can maximize your profit. And so the challenge was that if we could get that done, we would see that one, we could automate the way that our underwriters automate the decision making processes, and also in terms of business efficiency, we could reduce the turnaround time to process each particular loan. As a role as a company, we wanted to be able to achieve more, to be able to process loans faster, to be able to make decisions faster, and at the same time as accurately as possible. And so I'll just give you a brief how we went about solving this. First and foremost, we went about discussing with the stakeholders, understanding what's the risk understanding of the customer is. We also discussed with the underwriting team, who were actually the primary supplier of the data, to understand. Okay, so there's something we call the DTI, that's the debt to income ratio. So there was a particular number that the company uses to be able to calculate what the monthly offer for the client will be. And then based on that understanding, we made a couple of assumptions, key assumptions, then also which would actually prove very pivotal in the future engineering process, which I will talk about later. And so let me start with the data collection. We first of all we collected the data based on the previous monthly offers, the maximum affordable offers, and we collected that for a period of say like a year, and ended up with about 13,000 rows of customer data, I think. Then also we collected the customers' demographics, their income data, and then some of the variables that we're able to extract from their bank statement, which form the whole consolidated form of the data. And so this works in two pipelines. Already we had an established pipelines that extracts information from the electronic versions of the bank statements. So that's where we get then we're able to do some computation on their monthly credit, their number of credit they receive, the maximum credit, the average credit, and a couple of other interesting variables like that tell you what the position of the customer is at the end of the day. Then also we did some form of and for the ones that we could not get digitally, then we had to just do some form of optical character recognition to be able to extract those data, and then so we can cater for each segment of the kind of data that we had. Then also the next step was to do something called a data audit, because if you want your model to be really good, you have to do some form of data auditing, and then in the process of understanding your data, so you can have clean data to work with. So we removed deceased and non-functional loans, we removed out of school transactions, we did some preliminary data cleaning to remove some data that were probably not needed and all of that. And then we did some time scoping in our the EDA. That's to be able to pick what is the most stable period that we can model the data on. That's the data that sort of like the time period that can represent what is the optimum time period for each particular customer. And then we can so that is devoid of the shocks, devoid of external shocks, where we can see some form of stability. Then in doing that, then we can actually understand that, okay, right, we can model on this period, and this will reflect the behavior of the customers that we want to build into and all of that. And then I want to talk a bit about the tools and techniques that we worked with in doing this. So some of the techniques, I'll talk about a couple of techniques for the feature selection process. And so we use we calculate the IV method for each particular column. That's to just find out what the information value, right? To in order to be able to pick okay, so which of those columns will tell us some more about the customer, which ones are not really necessary, just contribute some form of noise into the model. Then in the selection, the final model selection, we used a process called a stepwise AIC. That's the Akaike information criterion to actually pick which of these particular features eventually give us the kind of the most optimum information value, the kind of input into the model that will tell us so much more than we as we are regressing against the target variable. So let me just talk a bit about the data here and what the data looked like. So I don't know if we had about 30,000 rows of data, and about that's 30,000 observation and 41 features, which was eventually reduced to say about 14 to 15 features thereabouts. And then so then we did the data the modeling phase took a 60-20-20 split. That's a 60% training and 20% validation, and then 20% testing. That's aside from some out of sample data to back test in the mail to just see how the model will perform even with not out of the sample or the time period that we chose. And then then in cleaning the data, some of the libraries that I use, I'll just mention them briefly. Pandas and Dask, that's for the distributed computing version of Pandas, to be able to clean the data, to analyze the structures of the data. Then we also use Sciplots, Seaborn, and Matplotlib to do visual analysis, and some graph were also done with Plotly, to just make the interaction more visuals. And the EDA, with doing some time analysis, showed us what the most stable period of the data was, and to look at, okay, so this is where we can model, as I discussed earlier. Then of course, the library, so use the scikit-learn library to be able to build some of the models, access some of the models that we eventually tried to use to build. We tried a logistic regression, we tried a cat-based regression, we tried a light GBM, and a random forest, and decision trees, and linear regression. So at the end of the day, to just see which one of them gives us the best process. And of course, in order to optimize the model, we tried different tuning some of the hyperparameters of the models that we're using, and also testing on different samples to see which particular period gives us the best metric. And since it's a regression model, so the typical metric we're trying to look for was our adjusted R squared, to see what's the level of the adjusted R squared on the training set, on the validation set, and eventually on the testing set, which is the one that actually matters the most. And then also, because we had already binned the data by income groups, that's the high income earners and low income earners and the medium income earners, and then we tested the data on those buckets to see, okay, what the model was doing and what we can learn per each of the particular income groups, and then to see that. And so eventually, in selecting the model that we used, to the eventual model, so the cat boost regressor gave the best R squared. But eventually we settled on a logistic regression because when we did that, and it gave us the more generalized, the most generalized model, the model that generalized the best. And we wanted to sacrifice some accuracy for better generalization, because the more representative of the results, so the kind of clients that we deal with, the better it is that we can actually be able to minimize our risk and maximize the profit across loan bounds. So it was not as much as, okay, let's just minimize our risk here. We also need to maximize the profit. That means we need to suggest a higher or more affordable amount to the people in the high income earners, and a lower affordable amount to the people in the low income, and be able to look at risk in both ways. So eventually we ended up with some comfortable R squared metric. The RMSE too, very comfortable RMSE. That's the square error, the error. The error between where we want to be and where we are, and all of that. So yeah, so we were able to do that. And then some challenges I will face, and first of all, that's in the feature selection, and also in some of the particular variables that enter the model. I realized, I remember that I had to retrain the model after looking at some of the results, and I saw that a particular variable, which was a loan amount, was actually throwing the model off because it was actually too predictive. And so if you take away the loan amount from the variable, the model breaks down and the results come poor. So we had to remove that feature particularly and try to optimize the model without it in order to get a stable result. And also in the deployment phase, we had to ask a couple of decisions. Do we want to create an API for this and expose another API because of security reasons, or do we just want to model? We don't just want to model on what we have, incorporate our model into an existing pipeline, and then send the result as part of an API already sending results, so we can limit our security exposure. Eventually, we started for the later option, which in turn proved really, really good. So another library that we used. The scaling transformation pipeline, and then in order to be able to deploy it, of course, compute resources on AWS, Node.js for the back end, and eventually we built a metrics front end to be seen to, in order to be able to see what the input of the data is and what the output is, and be able to look at what is going on at the back end. And also eventually how we got to deploy that as a service to the customers that were being used. Now this project is super important to me because of the three value that it brings. And first and foremost, it cuts underwriting time. That's the time taken to process a particular loan and to get what the result will be at the end of the day. By over hours. Typically you will want to take like more than an hour, 2 hours to look at a loan application, to process it through all the Excel templates, and to be able to find out, okay, and then go through a process, 2 steps, to actually witness a final approval, and this is what it will look like. But because we have built some form of automation into the system, the time taken will be reduced in order to achieve that. This does not necessarily mean that you have we have removed the human input. It's still needed, but the time taken to actually consider a particular loan is actually been automated. So what the underwriters look at is see what the figure that has been returned by the model, see what the inputs and the output look like, and make a decision on that. And then as a bank, the entire process of approving loans becomes seamless and simpler. And also because some form of decisioning, can be taken across different loan bands, and we can actually help us in order to be able to maximize the kind of offer that we're giving the clients, depending on which particular bucket you belong to. And so what improvements will I make to the model, right? So I think the first key issue with this particular model that I discovered was that it was built on gross income, right? You can't typically tell what the financial position of the person is based on their gross income. You need to actually find out what their net income is and look at what their net income is spread over a period of time, then build a DTI on that, because it's actually easy, because that way you tell what the true position of a customer is in building that. And so if I'm building that again, if I'm going to put another improvement, just look at what is the actual the net income of the model, and a couple of other things that we do in terms of the way they served and in terms of the way the stakeholders are carried along and all of that. So that's what's about it for this particular project. There are screenshots and things I cannot share because this proprietary information, but other things to support it, I mean, if it's needed, can be discussed. So thank you so much for the video. Thank you for listening, for watching. Have a pleasant time.